You've built your career at the intersection of science, sustainability, and social impact. What moment made you realize this was your life's mission?
Thank you so much for that question. For me, I will really say that the moment that made me see that firstly there has to be a change in my mindset in how I view things was my exposure to the mining industry. So I had an opportunity in my early, I think I was 20 years old, if not mistaken, where I had to work in the mining industry, specifically a gold mining industry. And really the exposure to the uh, mountains and people call them that mountains of tailings and mountains of tailings dams. That is another word that is used. It's actually one thing that made me realize that no, because of the problems that I've seen then as a young a young person to say no, these tailings that are really just occupying such big areas of space in our land, contaminating our water, contaminating our environment. There should be a solution for this. So really for me, that was that. And everything I believe was really built on that. And now when I reflect back, and I think the question is so aligned because when I reflect back in terms of the work that I'm doing currently, it always takes me back to that to the time when I was in the mining industry, seeing all these tailings of gold tailings or gold mine tailings, and now being bothered by this waste. That this waste is surely contaminating our soils, contaminating our water, polluting our environment. There should be something that needs to be done. And I think from that, the change of that mindset is what actually now prompted me to even go back to school, study further. And my pursuit for education also to study further, whether it's master's, was a PhD, it was so that I come with solution. I investigate solutions to solve these problems that I had experienced or was exposed to in the mining sector.
So that's how you basically went on to move on a career in they call it chemical engineering, right? You're a
Yeah.
doctor in the head of the department of the chemical engineering in, I think, UJ. So growing up in South Africa, like what early experiences shaped your perspective on waste, resources, and basically inequality to, because I saw your TEDx talk, you mentioned concepts like using waste to propel or make sure the economy thrives in a way, but I'm sure you can explain those concepts a bit better than I can just that I've just said to you just now, because I think it's a very interesting concept that you've done with your researchers in terms of solutions and everything. So could you just please channel us along those perspectives and those experiences that you've enjoyed in your career?
Mm. So yes, you have mentioned, I think two things that you have mentioned. One, being a chemical engineer. So I am a chemical engineer by profession and studied chemical engineering in my undergraduate up to a master's level, and I did a PhD in civil engineering. And the reason really why civil engineering then was that when I wanted to do a PhD in chemical engineering, we did not have that program in the department. Hence, then my supervisors then decided that no, I needed to look for a department that would allow me or is very close to the research that I wanted to do. So my research, even that, just really to emphasize on the point that the seed for me to pursue solutions or look or investigate solutions to solve these problems that I had experienced in the mining industry. I came back then for my master's. And even my master's was in wastewater treatment and focusing on some of the wastewater that is generated by the different industries, specifically in the mining sector. And I remember when I had to now go back to pursue my PhD, and take into consideration that I could not do it in chemical engineering, and the closest department was civil engineering. And even then, I'm the one that proposed the project to say that I have experienced this problem when I worked in the mining sector. Then I proposed it as my PhD project. So I would really say that this desire to solve problems, the desire to solve problems, and not for the sake of just solving problems, because you see the impact of these problems that we are experiencing in this time. I mean, in this instance here, we are talking about this solid waste and the pollution that is really caused by solid waste. And and really, so all of that through research that I've conducted over the years, then discovering that no, I mean, there's something beyond just managing waste material. I mean, yes, people think of waste and you think, okay, we should just manage waste. There are ways you cannot just, I mean, there's something beyond managing waste materials. And I think as I was developing in my career, also maturing in my career, then the concept of circular economy, probably also the conversation that we are going to have here, that to say that no, managing waste is that okay, you have waste, you must you might decide to sort out the waste. In this case, you are managing it, the tailings that are generated from the mining companies, mining processes, is what the dams, the mountains that I'm talking about, that is part of waste management. But you look at this, it's like when you now, and you are referring to the TED talk that I delivered, is that no, there's actually, this is not just waste. There are resources in this waste. There are there's an economy, a whole economy that is locked in what we see as waste. And I think now the discovery of that just excites me, because every single time someone talks about waste, I do not see that as a waste. The very first thing that I want to know is that what is it that is in that material that is considered as being waste, and what else can we do with it? And then that's when really the concept of circular economy comes in, where now we are really talking about looking at waste that okay, you have this waste material, now we see it as waste. Can we now begin to shift our mindset that we are no longer seeing this as a waste, we are now beginning to see this as a resource? And when we begin to see this as a resource, that is when now we talk about moving from the linear system, linear processes, to a closed loop process or system. That is what circular economy is really all about. And one of the things that I actually, as I was preparing, and one thing that I always share with my students also, is in terms of how a circular economy is so related and very close to how nature behaves, and you can take an example of a food chain system, where you have a grasshopper that will die being eaten by a rat, and we'll have a snake that will eat a rat, we'll have an eagle that will eat that snake, that all of that become a fertilizer, and then we use that, it fertilizes our soil, we can plant with that and so forth. And it is that regenerative systems that we are now beginning to talk about. So I really think that the problems that I was exposed to in terms of environmental pollution, and the curiosity, I was so curious to say that, yes, this might have been from a mining sector, but what else is happening in our industries? And then I discovered there's a lot that is happening. There are various waste materials that are being generated by different industries.
It's funny you mentioned waste, and now you're kind of using like innovations to almost come up with the tangible solutions towards making the economy thrive, because those are one of the innovations that we almost need as a country,
Yeah.
because there's acid mine drainage, and mine, obviously it's one of the most integral parts of the economy in the country. um there's guys like David Ikes. You have your spies in America who would mention, I mean, also in primary school, obviously you're always taught about that everything around us is made out of atoms, and atoms and everything that we currently have, those things, those that matter, right? It's the same thing. It's made out of the same thing, atoms. And when obviously science came up with new innovations, they found protons and neutrons.
Yeah.
But and also when they done more research again, in terms of their research and stuff like that, they also found that inside the protons, there's also holes, right? In those
Yeah.
holes, it's not actually
Mm,
holes, it's it's frequency, it's energy. So that energy, obviously, it's made up of everything around us. So basically, everything we could actually use it in whatever method that we try and use it on. I mean,
yeah.
there's also a guy like I like listening to I think is Joe Rogan. He mentions things about past civilizations, but I don't want to get into that concept
Mm, mm,
that we might have went on a singular or linear pathway, which is different from what the past civilization
yeah.
has been going with. Um, in terms of the circular economy, because it's an interesting conversation that I want us to dive deep in today's conversation. It's how programs are you initially having now with your research team, and is it a current um how can I put this standpoint that you're using to integrate or put in or pull in young talent into the economy so that they can have job employment and stuff like that.
Yeah. Yes, yes, definitely. And I think for me, obviously, it did not start as there to say that there's this green economy. Those are the things that I've discovered along the way to say that it is not just waste material. Like I'm saying that when you're talking circularity, and it is also something that I mean it's a what do I call it? I don't even want to call it a concept or what, but it is circular economy is still developing in South Africa, but there's marvelous work that is being conducted among different sectors where people now are really beginning to see waste as a resource. And we can really think about that. And we're talking about the issue of youth employment. We know in South Africa that South Africa probably among the top countries in the whole world with a very extremely high unemployment rate. And with that, for me, then I've seen that there's this hidden economy, if I should say that. There's this hidden green economy that is hidden in what we see as waste. And yes, definitely. And through the research that I'm doing, one of the things that I do is really to say that I want to move away from doing research for the sake of doing research. Doing research for the sake of producing graduates, whether masters or PhD, doing research for the sake of publishing. I think really that that is the mindset that most of us, especially in the academic space, we need to have to say that we cannot, with the problems that we are experiencing in our country, we cannot continue doing research for the sake of doing research for publications and for graduating students. So yes, definitely, when I design projects for my students, and the students that I have the opportunity to supervise, I design projects that are centered around real problems that we are experiencing, real problems that we are experiencing in our societies, in our industries, and specifically in the area of circular economy. And I've done work over the years, over the past decade also, where I've worked with different waste materials. And the story is the same. Can we turn these waste to something, a product that is valuable? It can be reused. We add more like increasing the lifespan of a material. So most of what is happening then when you're talking about circularity, most industries, what they tend to do is about you take, you use, you dispose of. And hence we have all this waste that is occupying our environment. But as I indicated, that circular economy then is closing that particular loop to say that no, we do not have to take, and the taking, unfortunately, most of the times is your natural resources. And I can give you an example, look, going back to the mining sector, your natural resources that we are extracting from our ground. Hence, we have the problem of acid mine drainage that after the extractions, the mines that are abandoned, we have water that will now penetrate through, and then it rises to the surface, and then we have a problem of acid mine drainage. Circular economy then is looking at the ways that yes, we have extracted from our natural resources, but what can we add value to the waste instead of continuously extracting from natural resources? And I'll give you an example. Waste when you're demolishing a building, you have a building that we are demolishing, and in other countries such as in China and other developing or developed countries, they're actually using that as aggregate. So you can use that as an aggregate that can completely replace some of your natural resources, such as your silica sand. You have a sand that you must extract from the land. So instead of now naturally extracting that from the land, can we now use this waste that we have? We can now pre-treat or the waste that we have. You would now get from your demolishing a building. That normally then the practice in South Africa, unfortunately, that waste end up in our landfills. So those are the things that are readily available to us to say that no, we do not have to continuously extract from our natural resources. Some of these products that we are looking for are actually products that are locked in waste materials. And I'll give you another example. Um, for my
Yeah.
PhD work, my work was basically to use a waste called phosphogypsum. A phosphogypsum is a waste that is generated when you are making phosphoric acid. And what is happening in South Africa with that waste, and you have that mainly in KZN and in Palabora in Limpopo. That waste is either pumped. I remember when I was doing my PhD, I discovered that some of this waste is actually pumped into the ocean. Most of it is also just landfilled. But now we are talking about critical minerals. That is not just waste, it's not just phosphogypsum. There are critical minerals that you will ordinary or normally want to extract from your natural resources. Go underground, let's extract these critical minerals. You, I discovered that that waste actually has some of these critical minerals. So we don't have to go deeper into our ground and really damage our ecosystem further. We can have some of these critical, extract some of these critical minerals from waste such as that. And there are so many other waste materials such as that. There's a study that I also conducted where I was actually extracting silica from one of the waste material. It's a waste material. You see there, people are crying, people that are working in that space, they want someone to actually take this waste, to dispose this waste off for them because they're paying penalties. That waste is not the core business. Their core business is to make your aluminum, your steel products and so forth. But in the process of doing that, they're generating this secondary waste. So they're looking for someone to please, I mean, we take this waste, do whatever with this waste. But it is not just waste. There are constituents that have value that we can recover from that. And that really, so we have, I think the beauty about most of the waste materials in South Africa is exactly that most of it is really not waste. It's really material or raw material or materials that we need to begin to see as raw material or inputs for other processes. And we can really begin to extract the waste that is, or the value added product that is contained or locked in those materials.
No, I remember our previous conversation. You mentioned that there's also waste that could be also used to create fuel, right? As a
Yes.
resource. That's
Yeah.
so there seems to be a lot of advances or ideology or ideas, I mean, that could create resources that could be also plushed back into the economy in order for us to maintain our livelihoods, right?
Yeah.
So my follow-up question to this concept overall is there progress in order for these resources or this fuel waste, or is it still just researching only, or is it just plashing money into research, or government is government involved in the whole process is yet?
Yeah. So I'll answer that in I think different levels. The answer is no, it is not just research that we are doing in our laboratories. There are many scholars that are really going all the way to implementing some of these solutions. And yes, government is also involved, a Department of Science and Innovation. If you can really just even just do a quick search on Google, there's what you call the waste RDI plan. And I think, if you're not mistaken, that is waste research development innovation plan. And that is where most of the work that has been done in South Africa over the years is actually packaged. There's also recently, not so recent, I think last day, if not mistaken, there was actually a strategy for STI for circular economy, which is science, technology, innovation for circular economy strategy that was developed and was launched, I think last day, if not mistaken. It's basically a strategy for circular economy, to say that how do we, as South Africa, begin to actually identify these opportunities and ensure that we are implementing some of these solutions that have been developed through research. And if you can also, the Department of Science and Innovation and the work that is done by CSIR, if you can really, through the waste RDI, you can see they actually package even the project that they're currently doing. There are many demonstrations around the country where the researchers, different stakeholders are demonstrating the work that they have discovered, innovations that they discovered through the research that they're doing. So no, it is not really a work that is we are excited about because it's in the laboratories or research as scale, but it is work that is out there, and it's mind blowing. If you can sort of, I do, when I see an opportunity or there's a call to attend some of this session, it is mind blowing. Like looking at what researchers in South Africa are doing, and you then discover that we do not lack innovation in South Africa. And think that, I mean, I get so excited when when I think about waste, but some of the things I'm saying that is mind blowing, because you look at people that I've never thought of this as being a resource or a product. And I think one of them that
True.
I'm really thinking about is it's a study that was conducted in one of the universities, where they are using even chicken feathers, as they are using chicken feathers, incorporating that into building and construction material. I mean, instead of now using that to as a heat, as a material that we can actually use to absorb heat. So if you are building with a product like that, you don't need your aircon and your heater. Now that talks to energy and electricity that you might be using. And there's so many of those amazing products. Is that, and I will just encourage anyone that will see this, go to the waste RTI and check the products or the projects that are being conducted all around the country. And it is mind blowing. And that's when you really see that there are really resources. There is really a whole new economy, green economy, that is locked in what we see as waste. And really through that, you mentioned waste to fuel. And I think one of the common one that we most of us know of is using waste of food waste to make your biogas and all that. But there's an amazing project that I did. I probably shared this the last time, that this project, I felt like, oh my God, this was also mind blowing. And it's a project where we were looking into the sewage sludge. Sewage sludge. So in South Africa, probably about 15% of that is being utilized as a fertilizer. But 85% of that is landfilling our land. So it's contaminating our environment and so forth. So in this project, it's really in collaboration with different stakeholders. There's an SME that is involved, there's government that is involved, that is funding the project. Initially, what we were planning to do was to just take sewage sludge, make biochar, make briquettes from that. Briquettes that you can use as a source of a secondary source of energy, renewable energy, whether you are cooking, or you can really use it as a co-firing product in your coal, and that is industrial. But in the process of now doing that, we have discovered that it is not only that we are using this one waste, but there are three products that we are now coming up with. There's a product, is your biochar that we initially envisioned that we are going to get from that process. We are now seeing that there's syngas that is coming out. I mean, that gas is a gas that we can purify, and that becomes our methane. Methane, you talk about your LPG, the gas, your cylinder that we use mainly in our kitchen. We can actually now really have that gas from sewage sludge. Not only that, we are also coming up with oil. You are producing oil in that process. It was just amazing and mind blowing. And really, for me, that shows that there's power in collaboration. Was this like, and I probably shared this, that I think about what 5 years or 4 years ago, an SMME knocked on my door to say, I've got this idea. And because I'm so passionate about what we call waste, I said, I'm ready to partner with you. Let's see how far we go with this. And then when we now bring all these minds together, we are now discovering that, oh my God, yes, we started with I mean, making briquettes. Look at what we are discovering. So just really, I think for me, that just shows that when collaboration, when there's people that share the same vision come together, there's just so much more that we can discover. And I think with the same mindset is that, like, the ways that I would maybe look at and think this is just ways that I can use for building and construction. If I can now look at other or collaborate with other scholars, SMMEs, the government, what else can we develop from that? And another, I think, example that I just want to share briefly is, I remember there was a time when I was invited in one of the in one of the conferences, and in that conference, so people were presenting is all good, and someone was presenting about uh coal fines. You know, like when you, I mean, ESCOM use coals I mean, to generate electricity. But in the process of all of that, whether you are transporting the coal and all that, there are fines that that are generated, and that fine, those fines cannot be used because it's like fines. It's not a coal. It's fines, 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 and so, and it's considered as being waste material because it cannot be used. So over the years, I've worked with that. I managed to, I mean, come up with an innovation that we can densify that. So from the fines, we can make coal from that. So that was me, and the research that I'm doing, still doing that. But in that conference, someone said something that changed, my perspective altogether. And he said something like, what if we reimagined coal fines? But instead of just looking at them as a raw material, or even coal as a raw material to just generate electricity, the critical minerals that we are looking for, we begin to extract them from that. And that really changed that. Oh, the fines that I was just looking at, that okay, I can just really let me use a binder, combine these, make a coal, and we can let's get electricity, let's get another source of renewable energy. Someone is saying, in fact, those coal fines, there are critical minerals in that. So yes, it's ways that we can just combine, make a binder, solidify it, densificate it, and use a binder, make a coal. But another now mindset is that no, instead of just doing that, you can firstly recover all the resources that are there, which are critical minerals. And so that is also the work that I'm currently doing. It's exciting. I think when you now open yourself up to say that I do not know everything, there are people that are wearing different lenses. And when you now open yourself up to say, I want to collaborate, let's hear your view. I'm a chemical engineer, and the work that I'm doing is multidisciplinary, is trans, is interdisciplinary. And in all those spaces, because I'm working with different people from different disciplines, people come with different perspectives. And to say that, no, 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 you might have been looking at it like this from your experiences, civil engineering, you take waste, you use it for building and construction. There are resources in this waste. Before you take it there, can we extract? And once we are done with the extraction, we'll give you the waste. Then you modify it, you strengthen it, and we use it for building and construction. I don't even know, Gucci, I answered your question, but I think you see the excitement and the passion I have about waste.
Most definitely. So don't worry.
Okay.
So it's yes, it's great excitement for sure. But now I want to ask if there were like challenges, in terms of after researching and doing all the work that you've been doing right now as a PhD scholar, um, challenges in terms of commercializing the idea, right? Putting it into the shelves, whether it's ShopRites, whether it's different brands in the country that's were able to advertise or for people to start actually utilizing these resources in terms of scale. And also exportation has there also been those thoughts in terms of selling outside the country or people talk about gatekeepers. Have you ever experienced gatekeepers in this landscape?
And so I'll say that, especially secular economy, and I think from what I've already shared is that you can literally come up with a new product with every waste that we are handling, and not just one product, different products. For instance, if I'm dealing with say coal fines, let me stick to that one. If I'm dealing with coal fines, I can recover the critical minerals, so those becomes products. I can use the after now I've extracted all these critical minerals, the waste that is remaining, I can further work with that to make other products. But remember that now when we are doing that, so we're developing new products, continuously developing new products, but the standardization is not keeping up with that. So one of the challenges that we are experiencing in the space, it is the issue of standards. To say that yes, I might have a product that is made 100% from waste. I've got product like that where I do not use cement, I do not use water to make building and construction materials, but there is no standard to actually develop it. So those are some of the real challenges that exist. But there's something also that I would like to share recently that I think it changed my perspective about how I view these barriers in South Africa. Yes, there are barriers in South Africa, but someone actually really made me change the whole my mindset, and I began to wear new lenses when I'm dealing with this. To say that some of these challenges in terms of regulations in South Africa and some of the red tapes, because I mean you cannot I cannot make a product and I take it out there, it is sold. Even if I have a product that it looks good when you look at it, if I should take that, for instance, a building material to a retailer, they want documentation. There's, I might have done that in the laboratory, tested that yes, it's working, certified. But most of them will say, okay, we want SAPS certification on this product. So, and because of that, someone said something that, and which is the reality that I've also experienced, that as researchers, we tend to spend so much time in our laboratories trying to perfect solutions or prototypes. We are perfecting prototypes in the laboratory instead of taking these prototypes for demonstration and perfecting them in real environments. I don't know if I'm making sense. So I have a product, I spent 10 years, and there's a prototype that we've been working on for over 10 years. It is now getting to the stage where we are going for a demonstration. We're now in the stage where we are building models for that, building a house and so forth. But it did not have to take us that long to get where we are today. And it took us that long because we spent so much time to perfect things, only to say that then we are excited at the end. Yes, I've developed this great innovation. You go out there for funding, you go out there, and the funders are telling you that no, where's the have you done environmental related I mean there are regulations that governs this. If you were to build this, have
Mm.
you tested this in this and that, you know? So I think then really that changed the entire perspective about how I conduct the research, and also a message that I would like to share, especially for the innovators that are in the academic space, to say that once we have that first prototype, you don't need to perfect it 20 times, 100 times for you to see that it works. If it is a clean binder that we have developed, take that, go and build a road. Let the cars drive on that. I mean, we have the asides that we can use for demonstrations. Let's test it in the real environment. See if these things work. And then I think after we have done that, we are already, so we are talking, when you're talking about technology, we also, you have different technology readiness level. And it begins from, I mean, from the lower level to the higher level. So for as long as I remain in the laboratory, I perfected it, can be perfect in the laboratory. You see that in terms of your TRL, it still remains a TRL4. It does not move from that. Then the moment you are like, now you spend 10 years perfecting that, you are ready for that technology to be funded. When you go out there, the funders are saying, no, we need TRL9. But for you to move from your 3 or 4 TRL to TRL9, it requires you that you should have demonstrated this in the real environment. So I think really after that perspective, I began to also just preach the gospel of demonstration, demonstration, demonstrations. Once we have that prototype, we have tested that it works, go out there and demonstrate. Take that material. You say that we have a building and construction material, build a house. Let's see how it's going to behave, because that is the only way you're going to actually see that, okay, this thing is actually, it is really working according to what I've discovered in the lab, that it has these characteristics of being used as a material for building a house. So I would really say that yes, one of that is that yes, before we even go out for funding, we are the ones that are shooting ourselves on the foot, because we spend so much time. And that's the thing, in spending so much time in doing that, we are not even engaging or involving the right stakeholders. So I think it's important that before we even, I think at the point of now, there's this great idea: bring in the relevant stakeholders on the table, bring in people that are working with environmental regulations, people that are working with standardizations, the industry must also be on board, because those will be the people that are supplying you with this raw material, which to them is waste. So bring in all these relevant stakeholders. And I think once you have done all of that, now the next step, obviously, I mean, if any funder is very cautious of funding something that is new, you need to de-risk that. So if we're not beginning with that, with all these relevant stakeholders on the table, and we are now beginning to taking our technology readiness level to a higher level, we are now beginning to talk about de-risking. So yes, like I'm saying, that funding is a problem, but how we can actually work around that is that all these innovations that we are coming up with, ensure that we are really focusing on de-risking them, and ensuring that we do not really, when you go out there, a funder can look at it and say, okay, we have done, fully done the de-risking, and I can actually put my money into this. And I think the other one of the challenges is we are talking about waste. It is really there to say that it is not waste. No, that mindset, that the shift in our mind to say that we need to begin to see this as raw material, as resources. And I
Mm.
think the moment we begin to see that, this when now we're beginning to unlock the green economy that I'm referring to, do that. This is not just waste material. We're not just talking waste management. We are really talking about resource recovery from waste, beneficiating the waste, and coming up with new products from there. So yes, now I've experienced many challenges, and I think really most of them are founded in that. The foundation is that you need to de-risk some of these innovations and technologies that we are developing, and we cannot de-risk them in isolation, working alone in a silo. You need the relevant people. Even before take, I mean, you have made these products, take them out there. If it's a brick, get a constructor. Let them build some of their houses with your material. That is some of the processes that we can use for de-risking. So and the other thing that I want to say, that someone that really shared this insight with me, to say that where regulations are so stringent and so tight, you can actually do your demonstrations outside South Africa. Can do a demonstration in other countries in Africa and so forth. Because if you can really zoom into the problems that we are experiencing, most of these problems are common problems, similar problems. There's a problem of potholes almost in every country in the world. You have developed a solution here, but because of the regulations, it takes longer for you to get where you want to go. reach out to other countries, go out, go and demonstrate out there. And there's a very inspiring entrepreneur who is a physicist, 10 innovator, and now fully focusing in her business. And she actually did that, develop an innovation, but because of a regulation in South Africa, she could not. It was difficult for her to demonstrate in a bigger scale. She went out to Europe, demonstrated that it was a success. And now countries in Europe are funding her style, research innovation. Now when she comes back, de-risk, the business is the innovation de-risk and all that. And then now people in South Africa are now throwing in money to fund the work and the innovation. So I think those are really some of the things to say that no, if really there are boundaries in South Africa that are preventing you from implementing some of this innovation, think outside the box. The box can be outside South Africa. What else can I do outside South Africa? Can I go and demonstrate elsewhere? And once that is done, my technology readiness level is at higher level. I can really come back to say, I've demonstrated this in the UK. I've demonstrated this somewhere in Africa. And the product is working, the solution is working, is solving the problems that we wanted to solve. Can I be funded? And then look, I think most of the times then people, unfortunately, it is unfortunate that sometimes it takes that the people outside must see that something is working before you can bring it home for people in home to actually also just see that your innovation is working.
Thank you so much for coming through to the platform, Tebogo, Mashifana.